Hi, thank you all. So today we're talking about WinterTC and about server-side JavaScript runtimes. You might have heard of WinterCG, or the Web Interpretable Runtimes Community Group, that was formed in 2002. This was
22.
Yeah, 2022. Sorry. This was a number of companies involved in server-side runtimes put together. Folks from Igalia, Node.js, Deno, like Cloudflare, to formalize come to an agreement to have a subset of web APIs that should be part of the of every server-side runtime. And the goal in general is to make JavaScript runtimes JavaScript runtimes other than browsers more interoperable, and also to kind of it's more interoperable, reduce lock-in, so that you could write for one runtime and run in any runtime, and enable as much shared code between browser and server as it makes sense. And the idea is to avoid lock-in and expand the common baseline functionality. We started as a W3C community group. This allowed open collaboration without needing you to become a W3C member, which, like for most companies, it requires paying membership dues, because obviously the W3C needs to make some money to fund their works. The thing is that due to IPR requirements in standards, and especially patents are complicated and they're a mess. Community groups are designed for open collaboration, but they cannot publish technical reports or standards. They are designed so that they can eventually become something like a working group or a technical committee that can publish standards, but community groups by themselves cannot. So we decided that we needed to publish a standard. So we have the minimum common API that was initially prototyped as part of WinterCG, that defines the common baseline functionality, the things that we expect every server-side runtime to have. These are present in Node.js, in Deno. These are present in Cloudflare Workers, Bun. So it's things like URL, the crypto API, fetch, set timeout, readable stream, the works. So in the last Web Engines Hackfest, we had a breakout session about WinterCG, and we had started to discuss before that, but we eventually decided that we needed a new standardization venue where we could publish standards. So we quickly found two options. There was W3C working group and an Ecma Technical Community. So it's WG versus TC. We had good discussions with both parties. The most straightforward option would have been W3C working group, because all of the legal machinery to go from a community group to a working group was already there. But there were things to consider, and the major points of interest for us would have been the invited expert policy. So folks who for folks who are experts on a subject matter or involved in the various matters that the standards are about. If they are not part of a member company that can pay member dues, or maybe they're an individual, maybe they're freelance or working on an open source project by themselves, or part of a small company, whatever. There is an invited expert policy. This is part of W3C, this is part of Ecma, this is part of other standards, other standards organization as well, I guess, so that they don't need to pay membership dues as an individual, or maybe if it's a very small company, so that the very few individuals that don't need to like that small company doesn't need. Yeah, so we wanted to continue the open collaboration as much as possible given the circumstances. So we needed a good invited expert policy. We needed a simple organizational structure that wouldn't get in the way too much, but also organizational help so that the standards body could help us and like, so it wouldn't get in the way, but it would also like help us publish standards that would be recognized and so on. And yeah, so we decided to make it like this is the Deno blog post. WinterCG is now WinterTC, and it became Ecma Technical Community number 55, or also known as WinterTC.
Yeah. So that happened in January this year, and we were obviously working on things prior to this, but as part of this, we really had to figure out what our charter is and like what we're actually working on. So what are we working on? One thing that we're working on is the minimum common API, which is like the subset of web APIs that we think every server-side JavaScript runtime should have. And I'll talk a little bit more about this in a second. As part of this, we also want to come up with a test suite, ideally reusing as many WPT tests as possible, because these are web APIs after all, to be able to measure like whether a runtime supports this this API, sort of like a conformance test suite. And then in addition to that, we're also thinking about standardizing additional APIs that are not relevant to servers directly, like a sockets API if we're talking over TCP and TLS, which is very necessary on servers to talk to databases and other services, but also things like a CLI API that allows you to do arbitrary file access, read environment variables, read process arguments, things like that. And these are like 3 different work streams inside of the technical committee. The main thing we're working on right now is the minimum common API, but there's also some other things that we're working on, which is figuring out how we can adapt web APIs like the fetch spec, for example, to work better in servers. I'll get more into that in a second. And then also we have some like server-driven use cases that are also useful for browsers. For example, streaming support in web crypto that we like wrote some specs for and are now working on upstreaming into the web crypto API in browsers directly. And those will hopefully ship both in servers and in browsers alike, and will sort of expand the common set for the benefit of both server and browser JavaScript people. So the minimum common API is a superset of the expose star web APIs. Some of you may have heard this. This is expose stars, like all the web APIs that are available in Shadow Realms, will be available in Shadow Realms, maybe, who knows. These are mostly compute-only APIs, like URL or URL pattern, that do not involve any async I/O. And then in addition to those expose star APIs, there's also some general purpose I/O APIs that are not available in expose star, like fetch or set timeout. They're still generally useful across servers and browsers. And the way that we've chosen these so far is mostly based on like what do server-side runtimes already support. Like if out of two out of 3 runtimes, for example, support fetch, we'll include this in the minimum set. And this is sort of like a mixed bag of all kinds of I/O APIs. There's like 4 or 5 I/O APIs and like, I don't know, 20, 30 non-I/O compute APIs. But yeah, you can see the full list on the website. And in the future, we actually want to expand this a little bit more to also cover things like web GPU, off-screen canvas, image DOM-rec, things that are necessary to do graphics, because a lot of the APIs designed for GPU and browsers, like especially web GPU, also work incredibly well on servers. Especially the compute APIs, those are really useful if you're doing like AI things on the server. You need to talk directly to a GPU, and like there's an API for this. So why not also make it available on the server? But we don't really want to mandate that everybody needs to support graphics APIs, because not all servers have GPUs. So we're working on sort of targeted conformance levels as well, where we have the minimum common API, and then we have like a version of the minimum common API for things that support graphics, and like things that have a file system, and things that need to do HTTP. So we're probably going to split this up a bit more, and there's going to be some things that are like really the minimum common set, which is like, I don't know, the URL global or readable stream. And then certain parts of the I/O APIs will be split up further into specific conformance levels that runtimes can like pick from depending on what their target audience is. Yeah, one of the really most complicated things that we're working on is figuring out how to make fetch work on the server. Fetch is like, it looks like a really simple API, right? It's like an async function that you pass a URL to, and it returns a response, and you can do some things with the response. But like fetch is a very, very complicated spec. And really, all of the fetch spec is just like figuring out how to go from what the user tells you to what the underlying HTTP call is that you're going to do. Like the fetch spec does not specify how exactly you write the bytes onto a TCP socket to do an H1 request. But it tells you like what headers you need to put in, what things need to be sanitized out, origins, cookies, all these kinds of things. And a lot of those things are not really relevant on a server. Like on a server, you do not have a currently active page, which means that you don't have an origin, you don't have a cookie jar, you don't have a refer that you can make fetch calls from. And because of that, there's a lot of things that you don't really need to protect against. If you don't have cookies, you don't need to protect against leaking those cookies across origins. If you don't have a refer, there's no way to set a refer outbound header on a fetch call, right? So there's a bunch of things in the fetch spec that are just not relevant to servers. And identifying all of those and figuring out how to address that and how to ideally upstream into the fetch spec a like system that allows servers to implement the fetch spec without all of these things is very difficult, and that's one thing we're working on. Another example of this is atomic redirect handling. I don't know how many of you know what this is, but in a browser, you cannot see redirects between like HTTP requests. When you make an HTTP request and it returns a redirect, that redirect is never exposed to the user. But if you're writing a proxy server, like it is very, very paramount that you can see that redirect request because you need to proxy that redirect request to the user. So like things like this just are fundamentally against what a server needs to be able to do with a fetch request. So as an example of this is like all of the headers that Chrome sends on a outbound fetch call to example.com from example.com. You can see there's some headers here that are like overridable, which means that like a user can set their own things through the headers option bag. But a lot of these API or a lot of these headers are things that are unforgeable, like they're unsettable by users. For example, all of the client hint things or everything prefixed with sec fetch. And a lot of these things are like, again, completely irrelevant to servers. Like servers don't have client hints. They don't like, what is a mobile server versus a desktop server? They don't have a default language because it's usually not a user that's using them, but like a set of users. And they don't have multiple modes. They don't have like document fetch calls and image fetch calls and script fetch calls. They just have like fetch calls that you make with a fetch API. They don't have cores. They don't have origins. So a lot of the things, as you can see in the spec, don't really make sense for us. So we've been working for the past couple months on figuring out what like the initial required changes are to the fetch spec that we actually need to make this work well on servers. And we've been looking a lot at like previous implementations of fetch on the server in Deno, in Node, in Cloudflare Workers, and like figuring out what everybody has figured out by themselves so far is actually not useful. So I'll just run through this list real quick, allowing various anti-spoofing headers for outgoing requests. So things like the origin header and all of the cores-related headers are not relevant on servers. All of the cookie-related headers actually need to be exposed to user code rather than being stripped out because there's no cookie jar, so servers need to be able to deal with cookies themselves. Yeah, the third point is the same thing. The fetch has some handling of content encoding and content length that is like, I'm going to call it broken. Some people may argue with me on this, but this like completely breaks proxies and it doesn't make sense in browsers either, really. It's just because you don't need to proxy requests on a server, or on a client, nobody ever notices things like this in a browser, that it's broken, because like the use case where it is broken just doesn't exist. And then like various options such as like the window options in the fetch, the request init bag for fetch, like, makes no sense. Credentials, refer policy, all of those. And then like response types such as opaque or opaque redirect, again, do not apply because we do not have to sanitize out specific responses because of their origin. And then there's some additional features that are never going to be relevant to browsers, but are very relevant to servers, like configuring the allowed protocols. You often need to do this if, for performance reasons, like in many cases, a local H1 connection is much faster than an H2 connection. You want to be able to programmatically say, like, this fetch request needs a certain needs to use a certain TLS certificate for MTLS. You want to maybe programmatically configure that a request goes through a specific HTTP proxy. You want to set custom CA certificates because you're talking to like an internal service that has self-signed certificates. Or maybe you want to disable connection pooling for performance reasons. So we want to figure out like what a good single extension point is that servers can integrate with fetch for these things that will not conflict with something that browsers will do in the future as well. And how do we want to do this? Well, we don't want to fork the fetch spec because the fetch spec is really complicated and it's already maintained by people that like know what they're doing. So we'd like to do this upstream, and we would love to discuss with you all how to best do this. We think that like a good way of doing this is starting on our side with like a high-level description of what actually is needed, like what needs to be changed, sort of like the slide 2 slides ago, and then working on some initially upstream maintenance work, like fixing bugs that we've encountered that maybe aren't relevant to browsers so much, but are relevant to servers, but that would also benefit browsers, and then making the spec more, cleaning up parts of the spec to make it easier to selectively ignore parts of it, like splitting up algorithms that are very large into smaller algorithms where you could like say, just ignore this part of the algorithm, or just ignore this algorithm entirely if you're on a server. And then investigate in the future whether it's feasible for the fetch spec to include sort of like a feature flag system of sorts where you can say like, if you are on a server, don't do this branch. If you're on a browser, do this branch. Yeah, and this is going to take a long time, presumably, but yeah, we are very, very interested in doing this and like have the resources to go and contribute upstream. So anybody working on the fetch spec, please talk to us.
Yeah, so a standard is worth little without a test suite. And the web platform already has a test suite, which is WPT, the Web Platform Test. So in order to be able to test the minimum common API and the modifications to fetch that were, well, like the parts of fetch that we're going to support in the various, in the minimum common API level, we are currently identifying a subset of WPT that tests the minimum common API, including the subset of fetch that works with the things that we're identifying. And the thing is that this test suite obviously should only rely on the minimum common API. It should not rely on things that are outside of it, because this is the thing that, like this subset of the web platform is the APIs that should be supported in the runtimes, and like obviously the test suite shouldn't have, ideally shouldn't have anything outside of that. So we sometimes need to modify tests. And as with fetch, we don't want to have a fork of WPT. We want to upstream our changes. And in some cases, that means splitting tests so that one test has everything that like we can use in the common minimum API, and then a different test has the stuff that is only relevant to browsers. And for the additional levels that we mentioned earlier, on top of the minimum common API, like file system level, socket, servers level, and so on, we would actually add, for file system it depends, but CLI we would definitely have to add custom tests on top, but it would be specific tests that we identify that would be on top of that. And if you are contributing to WPT, here's how you can make our life easier. Do not use, you shouldn't use document related APIs in tests unless, in some tests unless absolutely necessary. So, for example, if you, something that we were identifying in form data is that the constructor takes, the constructor has two optional parameters, which both are HTML elements. So in the minimum code API, we want to accept the constructor with no arguments, and then so maybe have one test file that tests it without any arguments, and then one that uses the HTML element at HTML form, so on. So here in terms of file names, where you have a .html test, that's only in the that would be only in the main thread, and it's already going to require a DOM. Like I know that Deno and I think maybe Node run some of those tests, but like we probably will not be including them in the minimum common API. So those are fine because they already kind of have a DOM. So if you're going to have a test that doesn't rely on, well, they have a document. If you are going to write a test that doesn't rely on anything that would not be that would be outside of the minimum common API, it would be best to have a .window.js or .any.js tests, and those. Like for those, it would be better to not use any document-related APIs.
And just to be clear, this is like really helpful for browsers too. Like if you have tests that rely on the document API, even though they don't need to, that means they don't run in workers and they don't run in service workers and they don't run in shared workers. And we have found multiple bugs so far in like shipping browsers where they were like exposing the wrong globals in workers and service workers, because they were not running some tests in workers and service workers because they were .html files. So like in general, if you do not need to use document APIs for testing something, do not use document APIs. Like make sure they run in workers and service workers too.
Yeah. So this is it. Our website of the WinterTC website is wintertc.org. Our GitHub, we had WinterCG still until like last month. We finally changed to WinterTC 55. Just WinterTC or just TC 55 were taken. But yeah, we took what we could get. You can check out the minimum core API proposal. And we have, in WinterTC, we have meetings every 2 weeks at Thursday, 6:30 p.m. Central European time. Central European / Central European Summer Time. And you must be either an Ecma member or a TC55 invited expert to attend. So we've tried, in the open spirit of collaboration, although we need, like, these members need to be restricted to members and invited experts for IPR and pattern reasons, we have tried to make the onboarding process as easy as possible. It's just you open an issue in the admin repo. And so if you can become an invited expert that way and attend the meetings. So thank you, and that's all.
Thanks.
Thank you, Andreu and Luca. First of all, anyone in the room with questions? We already have Sideshow Barker, yes. Wait, who's next?
There's one right here, one over there.
We have a question.
Well, I'll go ahead and ask, since I can't believe that nobody's asking anything about fetch, but I'm not going to talk about fetch. But does it make sense for the minimum common API to have a structured storage or database API? Is that something y'all been thinking about?
Yes, we have. So there are actually multiple server-side runtimes that implement like either local storage or the caches API, or both. And there's multiple runtimes that have looked at whether to support IndexedDB. But the problem with storage APIs that browsers have so far is that a lot of them do not work very well for server use cases. Like local storage, for example, is synchronous only, which you don't really want to block the event loop in servers, like much less than you want to do that in browsers. And IndexedDB is like incredibly complicated for what it provides. So yeah, maybe if we can sort of collectively come up with a new storage API for the web. I know there was the KV storage proposal a while ago. Yeah, exactly, WebSQL. Absolutely, we would totally do WebSQL. Like, I think all of the server-side runtimes that I know of already ship SQLite locally in their binary. So let's just expose it. Yeah, but then also things like the cache API, for example, there's like stuff in there that makes sense in a browser, like listing all the things in the cache, that if you want to back this by like a distributed cache on a server, does not make sense to list all the items in the cache, right? Like that's not a supported operation of most cache services. So we sort of need to adapt those a little bit for them to work well.
Yeah, I just have a question about given that we have been shifting from W3C Community group to a Ecma technical group, I'm wondering that if there are any commitment from the previous participation runtimes that there will still be a member of this TC and they will still be committing to adhere to the new standard so that this can be actually the end standard.
Yeah, so I mean, we haven't actually published any standard yet. So there's, oh, Usual, don't fall, please. We haven't actually published any standards, so there's nothing to actually adhere to right now. But like Deno and Cloudflare will adhere to the standard when we publish it, and Node probably will. Like with Node, it's always a bit difficult because it has to go through the technical steering committee.
It will adhere to some there are some things where Node.js, due to legacy reasons, is not 100% aligned with the web specs for a long time. And we don't see that changing, and we are not planning to allow that in the minimum common API. But this is one thing that we know where Node will not implement those parts of the standard, and but that's because they cannot because of legacy constraints, and that they will implement as much as possible.
Yeah. And one thing that we have done is make sure that everybody who's contributed to the W3C community group has the ability to join the TC meetings. So either because they're already members in Ecma or through becoming an invited expert. So we didn't we made sure that nobody was lost along the way while going from the community group to the TC.
Yeah, and in fact we chose part of why we chose Ecma is because a lot of the members of the community group were members of Ecma, and not so many were members of W3C. So that was a point in favor of Ecma.
I'm curious to hear a bit more about the test suite that you're working on. In particular, are there any tools that web platform test authors can use to help ensure that they adhere to that minimum set? Like, for example, are there any of the participating runtimes, do they have a WPT test runner or glue or anything like that?
Yeah, so that's a fantastic question. And the answer is yes, but it's not integrated into WPT.py. So both Deno and Node run WPTs. Let me see if I can open them here. Is it going to load? OK, it's not loading. Well, just believe me, they run. Oh, there we go. OK. So let's open, I don't know, compression. There's obviously a lot of tests here that don't run because we don't have service workers in Node or Deno, but you can, after you've written your tests by the next morning, there should be results on WPT.fyi, but we don't run them as part of the WPT test or suite as browsers do right now.
And well, there were some. We were thinking about making like ways to make this easier, but this is still under discussion. And,
Yeah, like we are actively interested in getting Deno and Node into wpt.py so that you can run them locally. It's just really difficult, unfortunately. Philip.
Are you actively converting these .html tests to .any.js tests? Because I think in my experience there are actually a lot of tests that could depend only on the minimum common API that require loading an HTML page.
Sorry, can you repeat that?
So in my experience, there are a lot of tests that could only depend on the minimum common API that actually require loading an HTML page. And I'm wondering if you are actively converting these?
Yes, we are. We've converted like, I don't know how many, but like hundreds of tests at this point from .html to any.js. And like, what are you looking for?
I'm trying to find the slides.
Oh, they're up there.
Right.
Yeah, so we have done like hundreds of these, and we'll do more. Like, yeah, this is actively something we're working on.
Good work.
Could you go back to the slide around the common API? I just have a general question about this, but there seems to be a trend towards moving more and more of these APIs from like the general browser into workers and stuff. And I'm wondering where you see this, if you see this trend over the next few years. I know there's, for example, open issues about like adding DOM to workers so that people can like work on DOM trees. Event target is, I think, in Deno. It's actually quite a useful API for servers. So, like, I don't think this is a good idea, but I'm just curious about like devil's advocate. Like, what about just shipping all of DOM into the web runtime? Like, what is the kind of trade-offs there? And that's one of my questions, if you want to.
Okay. Yeah. Do you want to go ahead?
Yeah. So obviously, there's a lot of complexity with shipping all of the DOM. There's the HTML parsing. There's a lot of APIs, a lot of complexity in various different. I don't know. Would you want to support shadow DOM in the server or in the server side? I think there's a lot of complexity, and but there seems to be a significant use case. So it's like, it depends. We were recently discussing a bit of this, I think, in the last meeting, because someone brought it up. I wouldn't see that in the minimum common API, but maybe possibly in one of the levels that sit on top of that.
Yeah.
Yeah.
I think specifically certain APIs are really useful. Like one thing that's really annoying with web components is server-side rendering, because the way they're invoked just makes it really difficult to do on a server. If you have enough of the DOM to be able to server-side render web components, that would be really useful. So that would be a good, useful subset. But I don't know, the regular canvas API, if you're not going to be displaying anything anyway, there's no point in painting to a canvas that you then don't see, right?
Well, there is a very common use case, which is to render a DOM tree so that you can capture capture a screenshot of it effectively. Mm-hmm. And so loads of websites like GitHub's social graph images, it's just like Chromium kicks up a browser to render an SVG and capture a screenshot. So I can imagine that kind of thing in a worker or like a WinterTC context. The other question I had is just a concern I wonder if you have had the same concern, and I wonder if there's ways to address it around this kind of bifurcation of the APIs and the complexity that burden on the developer, understanding that yes, we can all understand that we're going to shoehorn this bit of the algorithm into another bit that gets optionally run, but what kind of complexity does that expose to the developer to understand that this fetch algorithm is going to be substantially different on a runtime versus DOM or worker or something like that. Thank you.
I don't expect that there would be my understanding, my feeling is that in Deno or Node, developers don't really notice any anything different to the web, and if they do, it's things that make sense considering the differences.
Yeah,
right?
I think like a major part of this is that a lot of the things we're stripping out are things that like generally people on the web run into as like annoyances with a fetch spec. Like nobody really wants to deal with cores, right? It's like an unnecessary evil that you have to do because you're working on a browser, and those things not existing is like, it's nice. You don't have to deal with cores, right? But I think the biggest thing is that like the API 99% of use cases works and looks exactly the same. There's like a few edge cases that are different, and those obviously need to be documented. But for the majority of use cases, it's like you can run the same code in the browser and the server, and it'll just work.
Right. Thank you. I know that we're super excited and want to ask more questions, but this discussion's eating into the break, and I'd rather be the one.
Yes. Yes.
Thank you. I'd rather do the eating myself, so let's break, but we could ask questions over the break. Yeah, see you all at the hallway track, and a final round of applause for Luca and Andreu.